Good evening. In this video, we are going to talk about proposition 5 from book 1. Okay, so proposition 5 says that given an isosceles triangle, the angles on the base are equal. Besides, if we produce those two equal sides, then the angles under this base are also equal. Okay, so let's go to prove it. So first of all, please recall definition 20. With this definition, we know in an isosceles triangle, these two edges are equal. So we have AB is equal to AC. Good. And then because of postulate 2, we are able to produce a straight line, right? So let's just produce them. Great. And let us pick up a random point here on this produced straight line as D, okay? And then please recall proposition 3. Given two unequal straight lines, we are able to cut off from the longer one a substraight line that is equal to the shorter one. Great. And in this proposition, let's assume this is the longer one and AD is the shorter one. So let us cut off the longer one a shorter straight line. Okay, we will skip the steps in this proposition, and let's just assume F is a cutoff point. Okay, so which means we have AD is equal to AF. Good. And because of postulate 1, we can join a straight line from two given points. So let's just join DC and BF respectively. Great. And in the next step, please recall this proposition. In proposition 4, we know that if two triangles have this relationship, equal side, equal angle, equal side, then these two triangles are equal, right? So please have a look at this figure. We know that AB equals to AC and AF equals to AD. And this angle is shared by both of them. So we have angle DAC is equal to angle FAB. And because of proposition 4, we know that triangle DAC is equal to triangle FAB. Great. To be honest, these two triangles are congruent like this. But as Euclid had not defined the symbol or the definition of congruence, so let me just use equal here, okay? And from proposition 4, we know that if these two triangles are equal, then the other sides are also equal, which means BF is equal to CD. And the related angles are also equal. So we have this angle and this angles, they are equal. AFB equals to ADC. Great. And please have a look at the common notion 3. if we are subtracting the same thing from equals, the results are same. So we know these two equations, right? So we can, combining them, we get AF, let's subtract AC from it. It will be equal to subtracting AB from AD, right? Because they are equal and they minus the same thing, the results are equal, okay? So which means we have BD is equal to CF. Sorry, they should be reversed in wrong order. And let's just combine these three conditions together. So BF equals to CD and AFB, angle FB equals to angle ADC, and BD equals to CF. Then we know that this is still a side angle side relationship. So also using proposition 4, we know that triangle AFB is equal to triangle ADC. Great. And then we can conclude that these triangles are equal, so this angle must be equal to this angle. So we have angle DBC is equal to angle FCB. So this is one of the conclusions from proposition 5. So the angles under the base, right, they are equal. And then let's try to prove these two angles are equal, okay? So let us just have a closer look at these two relationships. So with the first pair of equal triangles, DAC equals to triangle FAB, we know that this angle and this angle are equal, right? So angle ABF is equal to angle ACD. Great. And look at another pair of equal triangles. AFB equals to triangle ADC. Then we have what? We have this angle is equal to this angle because these two triangles are equal. Okay, so we have angle FBC is equal to angle DCB here. They are equal and they are equal. And then please also use common notion 3. We know that if we subtract the equal things from the equal things, the results are equal. So we combining these two equations, we know that angle ABF minus angle CBF is equal to angle ACD minus angle DCB. Okay, so which means this angle minus this is equals to this angle minus this smaller one. So we have angle ABC is equal to angle ACB. So this is another conclusion from proposition 5, which is the angles on the base, they are equal. So with these two conclusions, I think we have completed the proof of proposition 5. Great. Thanks for watching. Have a good day.